Hello friends, welcome back. Hearty welcome to you. Let's look at this sequences and series. Previous year's IIT question. If A1, A2, A3 up to AN are in harmonic progression, then prove that A1, A2 plus A2, A3 plus A3, A4 like that up to n terms is equal to n minus 1 into A1 into AN. This is what we have to prove. So first we have been given that A1, A2, A3, AN are in harmonic progression. So that will be our starting point. So we'll write down first, we'll say that A1, A2, A3, all these terms are in harmonic progression, are in HP. We know that if these are in HP, then 1 by A1, 1 by A2, 1 by A3 are in AP, arithmetic progression. And we know in AP the common difference is given by second term minus first term, which is also equal to third term minus second term, which is also equal to fourth term minus third term, which is also equal to 1 by, we can also write it as 1 by AN minus of 1 by AN minus 1. Now, what we need is A1, A2. We have 1 by A2 minus 1 by A1, which is equal to common difference D. Now, what we will do, we'll try to convert whatever we have in terms of A1, A2. For that, I'll just check what is this 1 by A2 minus 1 by A1. I'll write down 1 by A2 minus 1 by A1 equal to D. Now, if I take LCM, I will get A1 minus A2 divided by A1 A2 is equal to D. Or what we want is A1 A2. So can I go ahead and write it as A1 A2 is equal to A1 minus A2 divided by D. We can say A1 A2 equal to A1 minus A2 by D. Similarly, what will be 1 by A2 minus 1 by A3 minus 1 by A2 is D. If I do that, I will get A2 A3 is equal to A2 minus A3 divided by D. Like this we can continue. So what will be our requirement, what we need, how it will become? Let us check that now. We'll go back and write down. So what we want is A1 A2 plus A2 A3 plus A3 A4. Like this we will go up to n terms, that is AN minus 1 and AN equal to how much? This is what we need. But we just now found out that A1 A2 equal to A1 minus A2 divided by D, and A2 A3 equal to A2 minus A3 divided by D, and A3 A4 equal to A3 minus A4 divided by D. Like that we will go till the last one, which is equal to A of n minus 1 minus of AN divided by D. Now you know that when you add all this, A2 A2 will cancel, A3 A3 will cancel. We are just left out with the first term and the last term, which is subtraction between them. So the answer we got is A1 minus AN into D. Now we don't know about D. Our solution should be in terms of A1, A2, AN and N. So what we will do, we'll find out what is the relation between AN and A1. For that, we'll go back here. We'll write down 1 by A1 is equal to 1 by A plus n minus 1 into D. What we are interested in D value, so I'll get this to this side. 1 by an minus 1 by a equal to n minus 1 into d? Or can I say a minus an divided by n minus 1 is equal to d, or 1 by d equal to n minus 1. We take the LCM also here, so it will be n minus 1. Also a1 it is. a1 or a, it's the same only. What we have here, a1 minus an by n minus 1 into a1 into an. Or can I say 1 by d equal to n minus 1 into a1 into an divided by a1 minus an. Now this value I can come back and substitute here, where I have a1 minus an divided by n. I can write down. I know that a1 minus an is as it is into 1 by d. 1 by d is nothing but equal to n minus 1 into a1 into an divided by again a1 minus an. We know that a1 minus a1 minus an will cancel. Our answer will be n minus 1 into a1 an, which is nothing but what we need to prove. So let's go back and look at this and see how we have solved it. We have been given that a1, a2, a3 are in harmonic progression. We have been given that a1, a2, a3 are in HP. Then we have to find out the value of a1, a2 plus a2, a3 up to n terms is equal to n minus 1 into a1, an. We are saying that a1, a2, a3 are in HP. That means 1 by a1, 1 by a2, 1 by a3 are in AP. And if they are in AP, we know that they have a common difference, which is nothing but second term minus first term, or third term minus second term. Now we know 1 by a2 minus 1 by a1 equal to common difference, and what we need is a1, a2. What we have is a1 minus a2 by a1, a2 equal to d. So we just try to get what is this value in terms of a1, a2 and d, that is a1 minus a2 by d. Now we observe that when we add all these terms, they all will cancel. They all will cancel. This one will cancel, this one will cancel, this one will cancel. At the end we are left out with a1 minus an divided by d. Now what the answer we want is n minus 1 into a1 an. That means I have to get a relation between a1 and an. For that we know an equal to a plus n minus 1 into d. So we can go there. An equal to 1 by an equal to 1 by a1 plus n minus 1 into d. When I subtract and try to get the value of d as the subject, I have d equal to a1 an by n minus 1 into a1 an, or 1 by d equal to n minus 1 into a1 an by a1 minus an. Now we can go back and substitute that in our last step. We will see that everything cancels with respect to a1 minus an, and we are left out with n minus 1 into a1 into an. So that's one previous year IIT question which I thought of sharing with you, was asked by one of the students, and we just try to solve it together. So just thought of sharing that with you. Thanks for your time and support. Please do let me know your feedback so that we can improve on the content and also the presentation. Thank you. Bye for now.